Hey everyone, welcome back to the NIIT YouTube channel. I'm Mukul and today we are upgrading our RAG app in a big way. In episode 3, we learned the basics of RAG. Now you're taking that simple chat with PDF app and turning it into a fast, efficient, multi-PDF RAG system that feels much closer to something you'd actually use in a production setup. We're adding faster PDF processing, faster embeddings, a FAISS vector store, persistent indexing, multi-PDF support, and a much cleaner L-cell chain. Alright, let's get into it. Before we jump into the code, let me quickly walk you through what's actually getting upgraded in this version. We've improved almost every part of the old RAG build, from how fast PDFs get extracted, to how quickly embeddings are generated, to how fast the search works, and even how the index behaves when you restart the app. We also added support for multiple PDFs and cleaned up the LCL flow so everything feels smoother and a lot more practical. So that's the upgrade roadmap. Now that you have the context, let's open up VS Code and begin building this project. We begin right at the top with our imports. We bring in Streamlit for the interface, PyPDF so we can read PDF files page by page, and all the LangChain components we need. The text splitter, the embedding model, the Llama model, FAISS for vector search, the prompt template, the output parser, and the utilities that help us connect everything. After the imports, we define a few simple settings: the Llama model we want to use, the embedding model, and the folder where our FAISS index will be stored. Keeping these at the top makes it easy to switch models later. Then we move into the functions that handle PDFs. The first one takes the uploaded PDFs and converts them into a structured list of documents. We go through each PDF, extract the text from every page, clean it, and label it with the file name and page number. By the end of this step, we have clean, structured documents ready for chunking. Next, we build the vector store. We split the documents into overlapping chunks, generate embeddings for each chunk, and feed everything into FAISS to create a searchable index. Once that index is ready, we save it to disk so the user doesn't have to process their PDFs again. Now we move into the RAG logic. There's a helper that formats the retrieved chunks by labeling them with the file name and page number. This makes the context easy for the model to understand and easy for the user to trust. Then we build the actual RAG chain. We define the prompt. The model must answer only using the provided context, avoid making things up, and mention page numbers when possible. We set up the Llama model with a low temperature so the answers stay grounded. Now, the chain itself works like this. We retrieve the relevant chunks, format them into readable context, pair that context with the user's question, run it through the prompt, send it to Llama, and finally clean the output. This gives us a clean, modular RAG pipeline. After that, we define the function that answers questions. It loads the FAISS index, turns it into a retriever, builds the RAG chain, and then returns the model's answer. This is the heart of the app. Now let's look at the Streamlit interface. At the top of the page, the user can type a question. If the index isn't built yet, we show a warning. If it exists, we run the pipeline and show the answer. In the sidebar, the user can upload one or more PDFs. When they click Submit and Process, we extract the text, split it, embed it, build the FAISS index, and save it. Once that's done, the app is ready to handle questions instantly. And at the end of the script, we simply run the Streamlit app when the file is executed. That's the full architecture: clean PDF processing, a persistent FAISS index, a structured RAG chain with LCL, and a simple Streamlit UI that turns your PDFs into a chat-ready knowledge base. Now that the code is ready, let's actually see how the app behaves in real life. I run the script, the Streamlit interface loads up in the browser, and right away you can see the two main sections: the question box in the center, and the upload and processing menu on the left. So I start by uploading a few PDFs. These could be job descriptions, research papers, policies, contracts, anything. The app reads each file, extracts the text, chunks it, embeds it, and builds the FAISS index behind the scenes. And the best part is, it only has to do this once. As soon as the index is created, it gets saved locally, so every future session opens instantly. The moment the index is ready, the app tells me I can start asking questions. So I type something like, what responsibilities are mentioned in this document? And here's where the upgrade really shows. The response comes back almost instantly. Llama 3 pulls the most relevant chunks from all the PDFs I uploaded, not just one, and generates a clean, grounded answer. It even references the specific pages that were used. There's no waiting for reprocessing, just a smooth, fast, reliable result every single time. This is exactly how a real production-style RAG workflow feels: quick setup, instant retrieval, and consistent performance. It takes our little episode 3 prototype and upgrades it into something you could actually use day to day. And that completes our upgraded RAG build. What started as a simple little chat with your PDF tool is now a fast, persistent, multi-document assistant that actually feels useful. And the exciting part is, we're only getting started. If these kinds of practical, real-world Gen AI projects help you learn better, let me know in the comments, and make sure you subscribe so you don't miss episode 7. We're building this series step by step, and the next episode takes things even deeper. Thank you for watching, and I'll see you in the next chapter.